One of the first things a Python developer learns are functions. Functions take input, process stuff, and return a result. The function is called, and here is the result. If you forget to return, the result will be none. This can lead to funny situations. For example, when the function prints something and then ends without returning. The output is now this. There is not a single Python developer that has not gone crazy over this output at one point. Avoiding problems like this is easy. Do not print in functions. Always explicitly return and let the calling code print the result. This function now has a clear input and output and can be reused everywhere. Now, what happens when I replace return with yield? The result is now a generator. Perhaps you have already seen this explanation. Yield turns a function into a generator. But what does that mean? To explain, let me start by creating another function. Function double numbers takes a list of numbers. It creates a new list, iterates numbers list, and adds each element times 2 to the result. The result is returned, and this is the output. Now, there's nothing wrong with this code. It is clear what is happening and it will work in any programming language. But it has a problem, and that is this list. In memory, two lists exist: numbers and result. For small lists, this is not a problem. But you can already imagine that this will become a problem when lists grow. At some point, poor Python will start to suffer. Now, the question is, do I need to create two lists? Look at the code again. I iterate the result with a for loop. Iterators deal with a single element each iteration. This is a perfect case for generators. Let me rewrite the code. That's it? You bet. Impressive. It is quite amazing how the yield statement turned the function into a generator. No matter how big the numbers list is, the double number generator will always have the same size. What I just did is called mapping. I mapped a list to a second list where each element is processed. But there is something interesting with the result list. It is not a list, but a generator. Once an element is requested by the for loop, the generator requests an element in the original list, processes it, and produces the result for the for loop. Initially, there's a bit of overhead to create the generator, but its size will remain the same, even if a huge list is iterated. So generators keep a reference to the original list. Once you recognize the concept of generators, you will notice them everywhere in Python. For example, the reversed function. If you want to reverse this list, there is really no need to create a new list. Why not create a generator that references the original list and iterates it from end to beginning? And of course, that is exactly what the reversed function in Python does. If I execute this code, I don't get a list, but a reversed class. And what have I iterated? Yep, that works. And there are more examples. What is the output here? It is a zip object that holds references to the numbers and names list. What if I iterate it? Elements are produced from the numbers and names list. So generators allow you to write lightweight functions that operate on lists and produce elements one by one with the yield statement. But I've got to tell you that not all generators are functions that yield. Generators can also be classes that implement dunder iter and dunder next. But that is out of the scope of this video, and I will go back to yield. During the last example, you might have thought, can't I do this with lambdas? And of course you can. Let me rewrite the code. So, what do you think the map function returns? A map object, which is a generator. And that works. So if the map function can also create a generator, why should I use a yield statement? Well, what if the logic gets a bit more complex? Let me show you a piece of code I am working on right now. I need to create a flat list from a directory tree. I want to do this asynchronously and cannot use Python's built-in walk function. This function gets a list of items, which can be files or folders. The top-level elements are yielded, and when an item is a folder, the folder contents are loaded. And the function calls itself with the items. This way, the tree structure is produced as a flat list. And by yielding the elements, there was no need to create a temporary list to return. And when I add a sleep to the loop, this function will be truly asynchronous, but I left it out to keep the code as short as possible. So I'm a big fan of the yield statement, and by now I hope you are too. So is it all good then? Well, it turns out there is still a case for returning a list instead of yielding individual elements, and that is indexing. Let me get back to this code. What happens if I access an element at index 2 of the doubled numbers list? Boom! That does not work. That is a property of generators. You can iterate them, but they do not allow random access. Of course, you can convert the generator to a list, but that will generate a copy again. So as a general rule, you can take away this. Returning a new list involves creating some copy of the original list, allows iteration and random access, and can be mutated. A generator maps elements of existing lists, allow iteration but not indexing, and the generator size does not depend on the original list, and is great to prepare for async await. So now go to your latest project and search for functions that return lists. Would yielding results be a better strategy? Of course, functions and lambdas are not the only way to map and filter lists, and if you want to see more ways to do it, click on this video. There you learn how to map and filter lists with list comprehensions.